So let's, first thing, let's define the max size, just a constant. So define the maximum size of the matrix so that we can declare a matrix. So max size, let's say it's 64. And now I'm going to create a matrix. So let's create a matrix here. So a char matrix. I'm going to call it matrix. And the size of this matrix is max size. And I'm going to initialize this matrix with 0 or an empty character, so that we are sure that there's no garbage already in memory. So we're just going to initialize the matrix. So let's just create a function that does that. So void init matrix, and I'm going to give it the matrix. So it's a char variable called matrix that has size, max size, and max size. And basically this is going to loop through the matrix and fill it with zeros. So for I starts at 0, I is less than max size, I++. And for j starts at 0, j is less than max size, j++ as well. And for every loop, basically we're gonna put inside matrix of I, j, the null character, 0. And that will initialize the matrix. So init matrix, matrix. Cool. Now let's write the actual function. So a function is of type void called f, and it takes the matrix. So it's going to be something char matrix, f size, dimension, max size, and then we're gonna give it the beg I, the beg j, or let's give it the and I here, and the beg j and the and j. So these are the coordinates of the beginning and the end of the submatrix that we want to recursively deal with. So if beg I equals and I, so the beginning, the index of the beginning equals the index of the end, it means that we're on top of just one single cell. Or the end of I equals the end, or sorry, the beginning of j equals the end of j. In that scenario, basically we're going to assign to the matrix I, j, hashtag character. Otherwise, we're going to call for 3 different subproblems. So the first one is f of something, and then f of something, and then f of something. So we said that, let's give it here the matrix, and we said that the beginning, the row, the beginning, the row number 1, the first row of the top left square starts at an address the same as its parent, so that's beg I. And for the end I, it'll be the beg I plus the and I divided by 2. The same thing for the columns, the j. So it's big J, same as its parent, and that's big J plus and J divided by 2. Alright, so that's the first subproblem. So let's deactivate these two functions. Let's call the f function, and let's give it the matrix, and let's give it n. So n, let's say, is 8, for example. So we're going to give it 0, 0, n, n. So here I have to add the type, that's int. And well, here that's big I and big J. Alright, so basically we have edited the matrix, but we did not print it out. So let's create another function to be able to see the content of the matrix. So it's basically the same as the init matrix, but when we traverse the matrix, instead of like assigning 0 to it, we're just gonna print it out to the screen. So it's print f, and then we want to print a character, and we give it that matrix of ij. And let's add here curly braces so that we can format the output to be to jump to the next line whenever we print an entire row. So let's call the print matrix. So let's change that. It'll be print matrix. So let's print matrix, and we give it the matrix, and let's give it also the size of the matrix. And here we have to add the size, and I starts up to that size n, and j starts printing up to that size n. So let's add the other subproblems. So the matrix is the matrix parameter is applied to all of them. So let's give it that. And for the bottom left square, the beginning of its row would be the big I plus the and I, all that divided by 2. So it's big I plus and I divided by 2. We said that we can omit the 1. We're going to test that. We're going to test and see whether we can or not. And the and row would be the and I. And for the column, the beginning column would be the big J. And the end column would be the big J plus the and J, all divided by 2. And for the last subproblem, the first, we're just gonna sort of swap these parameters. So what was for the I will be for the J, and what was for the J will be for the I. For example, here we divided the first parameter by 2, we left the second. For the other one, we're gonna divide the second parameter by 2, and we're gonna leave the first. So the first J would be the beginning J. Well, let's give it the I here first. So for the I, the first row would be the big I, and the last row would be the big I plus the and I, all divided by 2. And for the J, the first column would be the big J plus the and J divided by 2, and the last column would be AND J. Here, of course, I have supplied the wrong parameters, so it's from 0 to n, from 0 to n. Let's change that. And as you can see, this is the Sierpinski's triangle. This is the Sierpinski's triangles for n equals 8. And if I make this, for example, 16, it'll be a much bigger triangle that is created by smaller triangles. So this small triangle plus this small triangle plus this small triangle, we create a bigger triangle. Let's try that with 32. And you can see that the triangle got bigger. So this triangle plus this triangle plus this triangle to create a bigger triangle. And again, we can basically start the debugger to see the workflow of the function, the recursive workflow. So go here and activate the watches and the call stack and start executing instruction per instruction. So if we go to the next line, we have here the beginning of I, the end of I are different, and the beginning of J and the end of J are different, so we're not going to execute the statement inside the if condition. So we're going to move to the else statement, and we're going to execute the three different subproblems. And the first subproblem will make us call the bag of I, the end of I, the bag of J, and the end of J. So both and I and J got divided by 2, and same thing here, same thing. So a lot of call stacks, so you can just keep executing them one by one to see what is going to happen inside the call stack and how the order of these calls are made inside the memory. So thank you for watching this video. This has been Anibal Abidi with you. See you at the next video.